Okay, thank you very much for being here. My name is Pep, and today I'm going to talk about JSON Duality views. What are JSON Duality views? I don't remember what now. They don't print this anymore. And I remember when I was a kid, there were several books with phone numbers. And you had the yellow pages and you had the white pages. In the white pages, they don't print this anymore. Actually, this one is from 2013. Okay? And in the white pages, you had just names, addresses, and phone numbers. And in the yellow pages, you had the same, but with some pictures and some additional marketing content. Okay? And this brings the difference between SQL and NoSQL. So when I started with SQL, it was great because everything was very well defined. You had tables and columns, and all of a sudden somebody said, no, this is not good, this is very inefficient, we should have freedom. So we don't want to have tables, we want to have a flexible structure, we don't want to have tables, we want to have documents, and we want to have fields. And more or less, I always thought SQL was the white pages and NoSQL was the yellow pages. But the problem is that actually data is always a structure. Because if it's not a structure, it's not data. I mean, you can, finally we go to bytes and bits, and this is a structure. If we have images, images have formats, and the formats describe a structure that defines the content. The thing is that those structures can be quite simple. So, a table with a few columns, or more complex. You can have embedded documents and this kind of stuff. And developers love JSON because it is a very convenient format that you can use for a lot of things. So, what are JSON Duality views? Well, we store queries, and this is purely relational database, but those queries return JSON values. And those JSON values are documents. So they do not return one JSON document per row, they return one JSON document per structure we are reading. Okay? And the idea is to unify a structure and semi-structured data in a single view. So we can create tables where we have a structure, and then we can retrieve that structure as a JSON document. So this brings both worlds. We have the relational side with referential integrity, normalization, isolation, and all the stuff. And at the same time, we have JSON side with flexible documents and the support for REST API approaches without a lot of development, and also are development friendly. So this is outdated, no longer valid. The only thing that is valid is this is available since MySQL 9.4, and also it's available in FieldWave. So how we create a duality view? Well, here we have this We want the full structure, fully relational. We have users, products, shopping carts, and cart items. So it's easy. If we want to have a shopping cart, in the shopping cart belongs to a user. In the items, we have products. Okay? How do we create a JSON Duality view? To create a JSON Duality view, what we have is a function that creates JSON objects. And these JSON objects are accessible through the view. So you can't call this function from your code. Okay? This function is only available inside of our Duality view. And what does this view return? Well, it returns JSON objects. So we have an ID, a username, email, and member size. There's some data missing here, but it doesn't matter. We will see later. The problem is that JSON Duality views bring some restrictions. Okay? The first one. This has to be a base table. It can be a view, it can be a subselect, it can be a temporary table, it has to be a table. The second one, I can't apply any functions here. Okay? I can't apply operators. I can add or subtract or lower. I can't perform joins. So I can't do from users in a join, whatever. No. I can retrieve just from the base table. So it's also unsupported a word clause. I can filter here. I can group by, I can't. Okay, so what can I do? What I can do is call to other JSON objects to add them inside of my object. Okay? So the view is, it jumps into the JSON world. So what we do here, for example, if we want to retrieve a shopping cart, is this is the idea of the shopping cart. For the user, I create another object. The user is the same here in this table than in the shopping cart. So I can create sort of joins. Okay? And here for the items, as I have multiple items, instead of retrieving the items into just one object, what I do is I create an array of objects. Okay. Then I join the cart ID with the identifiers in the cart items. And this returns a shopping cart. So I have the status of the shopping cart, when it was created, the user, the items in the shopping cart. Okay, so how do we query those views? Well, first of all, we can do a full scan, and then we get all the list of shopping carts. We can do filtering with JSON functions. So I can say, okay, I want the shopping cart, I know the ID of the shopping cart, so I use JSON value for that specific shopping cart. Or for any other attribute in the JSON document. Or even for other elements, or even count the number of elements. In this case, for each cart, I want to count the numbers, the number of items in the shopping cart. Okay. Something important. When we add an array, usually we have null and null. And this means that if the elements from the array I'm retrieving are null, but the element exists, I will have a null value in my array. So let's imagine, for example, that I'm retrieving just some components of the product that are null. I would have a null element in my array. This means that in some cases I can make this query to return 1 for empty cards. Okay? While it should return 0. So in those cases, you need to define the array as absent or null. This will return an empty array, an array that contains a null. So here, the null items can be counted. We can also filter by nested documents. So in this case, for example, I'm searching for certain products, for the cards that contain certain products, sorry. Okay. Or the cards that contain products of a certain family. And how, okay, that's great, I have a view, but how can I add elements to that view? Obviously, I can insert elements on the underlying relational tables, and that's fine, and this should work. But I can also add elements to the view. So it's a view that I can update, or I can insert values in the view. To be able to do this, the first thing is I need to have a version that supports this. Enterprise for 9.4.5.6, probably 9.7, it will be community. And then I have to tweak a little bit the definition of the view. Here I have to say, okay, this object supports insert, update, and delete. This object here supports insert and update. This object here supports insert, update, and delete. You need to be extremely careful with this. Why? Because you can modify the underlying objects. We will see later. In this case, for example, we could create users or modify products. And how do we manage to lock these documents? Obviously, if we lock the underlying tables and records, this will work. But in the JSON world, usually you don't do this. So you just request data. This is quick, you get the answer, and another connection, not related to the database connection, will ask you for updating the data. How we control this? We control this with something called lockless optimistic concurrency control. This is, we don't lock. Okay? We will assume that we can perform the update. And how do we know if the data has changed or not? We know because we have the E-tag. The E-tag is a JSON document unique identifier. It identifies the state of that document. Okay? So you can't update a JSON document if you provide a different E-tag. The idea is, I check the shopping carts, and my shopping cart has the e-tag 1. Simplify. If I want to update the shopping cart, I will say, I want to update the shopping cart with e-tag 1. Okay. It's not an identifier in terms of where, it's an identifier inside of the document. Okay. So when I update, I will provide the e-tag. Okay. If the e-tags are different, the operation will fail. If the e-tags are the same, the operation will succeed. And the e-tag is generated automatically. You don't need to generate them, and is consistent. I mean, if you read several times the same rows, they will have the same tag. In this case, for example, I run this is a set of data that was generated by Claude, and he decided to use MySQL books. The AI knows me. So here in the update, we add the e-tag. Okay? It's a square array, 3 rows affected. More about this later. If I repeat the same with the same e-tag, it says no. The document in the database does not match that e-tag. So I can't update twice using the same e-tag. But I can run the update without e-tag. So this, you need to be careful. Okay? If the update does not include an e-tag, the update is executed properly, but you get a warning saying, you did not provide an e-tag. I guess you know what you are doing. Okay? This is an insert. Okay? Query okay, 7 rows affected. Why? Because actually, I changed the price of the products. So this insert inserted the shopping cart, but it also updated the price of the products. So when you specify the capabilities in the view, you need to be very careful, because if you say sub-documents can be inserted or can be updated, you can update things that you actually you didn't want it to update. Okay. How JSON duality views are executed. This is the part for me more. There's a table scan, then we materialize this, and then we perform a table scan from the materialized view. Even if I'm searching using something that should be the primary key in the shopping carts table. Okay. What this means is that even if we filter, it will scan completely the base table. And this explains why I think the use case is currently with this version, because I expect this to be fixed and somehow be able to push down conditions before the materialization. You should use small root tables. Important here, 1 second. The full scan, the indexes are used in the internally. Okay, so it's only when you retrieve the final document, you will perform a full scan of the base table. Okay, so here we are using indexes, okay, internally. Small root tables that usually you have in memory. So if you have any commas, your shopping carts will be in memory. Okay, so we will have to do a full scan of memory. Or when you know that you are going to scan all the documents. So if you are going to scan all the documents, it's the same that you do it through a duality view, or if you do it with your code. So remember, you can't do a word filtering inside of the JDV. You can't use views, and you can't use temporary tables. And I think I've been a bit too fast. That's all. I'm Pep, and this is Mortimer. You can reach me.
Quick one.